Hello, this is Algebra 2, topic 2-1 on the application of logs. So here we're going to manipulate common exponential functions that we can use logs to help us solve. We're going to start with the formula for compound interest. Well, let's first talk about what each letter represents. A is the final amount. P is the principal, that's how much money you start with. R is the rate, written as a decimal. T is the time in years. And N is the number of times compounded per year. So let's go ahead and put all this together for example number 1. Courtney wants to have $5,000 in her account. So that will be the final amount, $5,000. 12 years, that means that T equals 12. 7% interest, so 0.07 is my rate. Compounded quarterly, that means that N equals 4. We want to know what to invest initially. Well, that will be the P. Parentheses 1 plus 0.07 over 4 raised to the 4 times 12 power. Well, let's go ahead and simplify what we can. We still get that this is 5,000 equals P times 1 plus 0.07 over 4 is 1.0175 raised to the 48th power. So 5,000 equals 1.0175 raised to the 48th power times P. And the reason I'm not writing it out is because it gets a really ridiculous number. Well, I want to divide both sides by this really ridiculous number to get P. And since I have it in the calculator, I'm going to do 5,000 divided by my answer. And you can get that by hitting second and then the negative sign. This is going to give us the most accurate answer. And it tells us that P equals 2,174.29 cents. So how much is she going to need to invest? She's going to need to invest $2,174.29. So we didn't even need a logarithm to solve this. Let's go ahead and have a look at number 2. Well, Heather has $2,000 to invest, so that means that the P is 2,000. 10% means that R is 0.10. Semi-annually means twice a year. And we want to leave it until it is $5,000. So we want the amount to be $5,000. And we want to know how long. Well, let's go ahead and write our equation. The 5,000 equals the 2,000 times 1 plus 0.10 over 2 raised to the 2t power. Let's go ahead and simplify. I'm going to go ahead and divide by 2,000. I get that 2.5 equals 1.05 to the 2t power. Well, here my variable is in the exponent, so I'm going to need to use logs. So the log of 2.5 equals the log of 1.05 to the 2t. We will expand our logs, so now we get that the log of 2.5 equals 2t on the log of 1.05. Well, if I divide by the log of 1.05, I'll figure out what 2t is. So log of 2.5 divided by the log of 1.05. So 2t equals all of this mess, 18.78. Divide both sides by 2. And I get that this equals 9.39. Now, I can't leave it in there for 0.39 of a year and have it mean anything. So I'm going to have to round this up. To 9.5. Because it's semi-annually, that means that half the year they're going to go ahead and account for that interest again. And so that is our answer. Let's go ahead and take a look at example number 3. Scott invests $6,000, so that means the P is 6,000, at 8%, so my rate is 0.08. Quarterly, N equals 4. How long till it grows to 14,000? So A equals 14,000. All right, we'll go ahead and write our formula out. 14,000 equals 6,000 times 1 plus 0.08 over 4 to the 4t power. We're going to divide both sides by 6,000. I'm just going to leave this as a simplified fraction. 7/3 equals 1.02 to the 4t power. Well, now we take some logs. The log of 7/3 equals the log of 1.02 to the 4t power. Expand. The log of 7/3 equals 4t, the log of 1.02. Divide both sides by the log of 0.012 of 1.02. And I get that 4t equals, well, we want the log of 7/3 divided by the log of 1.02. And that gives us this crazy number of 42.79. We divide this by 4. And we get that t equals 10.70. Well, again, we can't do just 0.7 of a year, so we need to round up to t equals 10 3/4. So if he leaves it in there for 10 3/4 years, then it will grow up to $14,000. So it's a matter of finding your variables, plugging them in, simplifying it down until you need to use the log, expanding your log so that you can divide, and then solving. And then realizing that your answer has to be rounded to make sense. So let's go ahead and talk about example number 4. But first we need to talk about another type of exponential equation called a half-life equation. Here's the formula for it, and they've already listed what everything means, which is great. So the half-life of this isotope is 87.1 days. Well, half-life is H. So H equals 87.1. How much of a 2-gram sample? That's what we start with. So that's the original amount. N sub O equals 2. After 100 days, so T equals 100. So N equals 2 times 1/2 to the 100 over 87.1 power. Well, I can actually just type that directly into my calculator. 2 parentheses 1/2 raised to the 100 over 87.1 power. And I get 0.902. And unlike with our banks, where they only do the compounding every so often, half-lives don't have step programs. They are exact. So we don't need to do any kind of rounding here, except for rounding to 3 decimal places. For example number 5, this chromium has a half-life of 23 hours. So H equals 23. And we want 50 grams, so that's N to the 0 is 50, to decay to 40 grams. So N equals 40. All right, let's go ahead and fill this in. So 40 equals 50 times 1/2 to the T goes first over 23. Well, we need to go ahead and simplify this. So I'm going to divide both sides by 50. And we get 4/5 equals 1/2 to the T over 23 power. Take the log of both sides. So the log of 4/5 equals the log of 1/2 raised to the T over 23. Expand. The log of 4/5 equals T over 23 times the log of 1/2. Divide by the log of 1/2. Put that into our calculators. That will be the log of 4/5 divided by the log of 1/2. Gives us this number, which is 0.322 equals T over 23. We multiply both sides by 23, and we get 7.404 is about equal to T. So almost 7.5 hours. Moving on to our last example, example number 6. 35 kilograms of a 100 kilogram sample. So that means that N is 35, and N sub 0 is 100. And it remains after 12,000 years. So T is 12,000 years. We want to find the half-life. So our amount is 35 equals 100 times 1/2 to the 12,000 over h power. So 0.35 is 1/2 to that crazy power. We take the logs, expand, divide, and we take and do log of 0.35 over the log of 1/2 gives us this number, which is about 1.515. And what we're going to do is we're going to first need to multiply by h to get rid of these. So we have 12,000 equals 1.515 h, and then divide by 1.515, which we can do that by going 12,000 divided by our answer, and we get that 7923 is about h. And they said the nearest 100 years, so h equals 7,900. And so that's how you can use logs to solve interesting parts of exponential equations and formulas. Good luck on your assignment and have a good day.